I am Hafsa from Maths Online Coaching. Today we are going to solve a question paper of Pearson Edexcel International A Level, 13th January 2026, Pure Mathematics P2. Question number 8. Solve for theta greater than or equal to 0 less than 180. The equation 4 tan square 2 theta minus 30 degree plus 1 is equal to 49. Giving the answers to one decimal place. Here we have to solve our trigonometric equation in which theta is the variable to be determined and its value should lie between these values within this interval, theta greater than or equal to 0 and less than 180. So let us start the solution. 4 tan square 2 theta minus 30 degree plus 1 is equal to 49. First of all, we simplify this equation. 4 tan square 2 theta minus 30 degree is equal to 49 minus 1, which is 48. This is tan square 2 theta minus 30 degree is equal to 48 by 4, which is 12. Now, taking square root on both sides, we get tan 2 theta minus 30 degree is equal to plus minus square root 12. Here are the two values of tan theta, positive and negative. First one is tan 2 theta minus 30 degree is equal to plus square root 12. And the second is tan 2 theta minus 30 degree is equal to minus square root 12. Now, taking inverse, 2 theta minus 30 degree is equal to tan inverse square root 12. Similarly, 2 theta minus 30 degree is equal to tan inverse minus square root 12. Now, inverse of tan for square root 12 gives the angle 73 degree, 73.89 degree. This is the basic angle. Now we have to check the quadrants. There are 4 quadrants. Tan theta is positive in first quadrant and third quadrant, and it is negative in second and fourth quadrant. In first quadrant, we take the basic angle theta. In second quadrant, we take pi or 180 degree minus theta. In third, we take 180 plus theta. And in fourth quadrant, the angle is taken as 360 degree minus theta. So tan theta is positive in first and third quadrant and negative in second and fourth. So we have to take the values in all fourth quadrants. So 2 theta minus 30 degree will be equal to 73.89 in first quadrant. In second quadrant, it will be 180 minus 73.89, which gives 106.11. In third quadrant, it is 180 plus 73.89, which is equal to 253.89. And when we take this value in fourth quadrant, we have to subtract 73.89 from 360 degree, which is equal to 286.11. These are the 4 angles, which are the values of 2 theta minus 30 degree. Now, to calculate theta from here, we have to add 30 degree in all 4 angles and then divide it by 2 to get the value of theta as 51.9 degree, 68.1, 141.9 degree, and 158.1 degree. These are the values of theta. All these 4 values lie within the interval given in the statement, theta greater than or equal to 0 and less than 180. So these are the required values of theta. Now look at part number 2. Solve for x greater than or equal to 0 less than 2 pi. This is the interval given here. 2 tan x plus sin x plus 3 is equal to 0. Giving the answers in radians in the form k pi, where k is a rational constant. Here is another trigonometric equation which can be solved by simplifying it, and we have to take the value of x in radians within this interval from 0 to 2 pi. Now we solve this equation. 2 tan x sin x plus 3 is equal to 0. In this trigonometric equation, there are two trigonometric functions, sine and tan. And to simplify the trigonometric equation, we always have to convert the equation into a single trigonometric function. So first of all, we have to simplify this equation. We know that tan x is equal to sine x by cos x into sine x plus 3 is equal to 0. It gives 2 sine square x by cos x plus 3 is equal to 0, which is 2 sine square x plus 3 cos x is equal to 0. Here we have sine and cos. We have to convert this sine square into cos function so that we can solve the equation. We know by trigonometric identities that the value of sine square x is 1 minus cos square x. Use this value in this equation. 1 minus cos square x plus 3 cos x is equal to 0. And simplify. 2 minus 2 cos square x plus 3 cos x is equal to 0, which gives 2 cos square x minus 3 cos x minus 2 is equal to 0. Now, this is a quadratic equation in cos x. We can solve it by using formula or factorization. So factorize 4, 2 into 2 is 4. We can factorize it as minus 4 cos x plus cos x minus 2 is equal to 0, which gives 2 cos x minus 2 plus 1 into cos x minus 2 is equal to 0. It gives 2 cos x plus 1 into cos x minus 2 is equal to 0. It can be written as 2 cos x plus 1 is equal to 0 and cos x minus 2 is equal to 0. Here the value of cos x is equal to minus 1 by 2, and in this equation it is cos x is equal to 2. We know that the value of cos function lies in the interval minus 1 to 1, which is the range of cos function. So it cannot be equal to 2. Cos x cannot be equal to 2, so this is not possible. And its solution does not exist. Now look at this one. In this equation, the value of cos is negative. And we know that cos function is negative in second or third quadrant. The value of cos is negative in second or third. Here the reference angle or the basic angle, which can be taken as cos inverse 1 by 2, is pi by 3. 60 degree or pi by 3 in radians. So when we take the angle in second quadrant, it will be pi minus pi by 3. In second quadrant, here is pi. When we move to the second quadrant, it will be pi minus theta, and when we move to the third, it will be pi plus theta. So in second quadrant, the angle is pi minus pi by 3, and in third quadrant, angle will be pi plus pi by 3. Now this is 2 pi by 3, and this is 4 pi by 3. So the values of x are 2 pi by 3 and 4 pi by 3, which lies in the interval given in the statement that x is greater than or equal to 0 and less than 2 pi. It completes the solution to part number 2. Join us for further solutions. Thank you very much.